In this teaching material, we are going to go into detail about the wood firing process. It is important that a ceramic artist not get caught in the trap of thinking that some intrinsic value is added to a piece just because of the way it was fired, or because the process of making or firing was difficult. There is no magic in materials, nor in the making or firing process. The magic is in the really exceptional finished piece. Only the results achieved are important. To yield better outcome, wood selection is crucial in achieving our results. We split and stack the wood in preparation for a firing, then burn specific wood at certain times during a firing to promote melt and flow, speckling, and desired color blend interaction. Brief introduction of the firing process. In a normal scenario, fires are usually started in a lower firebox one at a time over a period of 2 hours. After about 4 hours, another potter takes over the firing and continues to stoke until it reaches around 537 degrees Celsius. At this point, the ash pit doors are bricked up and they switch to upper boxes. As the kiln approaches 537 degrees Celsius, lower doorways are bricked up and stoking is transferred to the doors above. These doors can be opened and closed for stoking until the end of the firing. As the wood burns, ashes, embers, and partially combusted wood will fall into the ash pit below where they continue to burn and serve to ignite new loaded wood in the firebox. If the wood above the embers can be elevated at this moment, it will combust better because the incoming primary air full of oxygen from above encircles the wood. Vitrification. When the temperature is at around 800 degrees Celsius, the clay starts to harden as soda, potash, lime, and other impurities in the clay begin to melt, and then to glue the clay particles together. By doing this, the clay body will be strengthened and more so as the temperature rises. This process is called vitrification. Burnout. The carbon or vegetable matter in the clay will start to burn out when a red glow is reached, but the burning out will only be completed at around 900 degrees Celsius. When not completely burned out, black marks will be formed because of unburned carbon. When the temperature reaches around 350 to 700 degrees Celsius, a ceramic change takes place, which permanently changes the soft clay into a pot, which is something rock hard that can never be softened by water. Again, if the firing goes too fast, hitting 600 degrees Celsius, a rapid release of water may also cause the pots to crack. The carbon, or vegetable matter in the clay, will not start to burn out until a red glow is reached. When this red glow temperature reaches, we should keep burning this matter until reaching 900 degrees Celsius, otherwise black marks will be formed because of unburned carbon. Oxidizing and reducing. The different ratios of gases inside the kiln will affect both the clay and the glazes. A firing with a high percentage of oxygen intake is called oxidizing, and a firing with a very low percentage is called reducing. The results of these two firing conditions are the changes of color in the clay and the glazes. For example, with a low percentage of air, the clayworks will turn gray or black, whereas with a high percentage of air, they will turn red. Soaking. Soaking is carried out to make sure that all the clayworks are merged in a maturing temperature. Test specimens should be drawn both from top and bottom of the chamber. If the temperature is uneven, the maturing temperature should be kept for another 1 or 2 hours, allowing the clayworks to set with the glaze potters are looking for. This is called soaking. Graphic illustration of temperature variations. To have a clear picture of temperature variations, a graphic illustration of how the temperature changes hourly on firing is needed. Graphs which show the hourly temperature rise of each firing can be established to evaluate the results from previous firings and can be used as the basis for conducting the next firing. The reason to take the temperatures of firing so seriously is that they will affect the final clayworks. As a result, some of the typical tips for handling the temperature of firing are recommended as follows.